Okay guys, with no further ado, let's get in and get started with parametric modeling using FreeCAD. So last time around, we got our introduction using Tinkercad and we did something called Boolean operations for making a little project box, which is pretty cool. But if you can think about it, let's say you wanted a different size of box. Well, you'd basically have to go back into Tinkercad and change a bunch of settings. Today I'm going to be showing you how you can create a project box that you'll be able to change settings on and have it readjust to your new settings without having to do any additional work. That's the power of parametric modeling. So I'm going to be using a program called FreeCAD here, which is a free open source solution that's available for Linux, Mac, and Windows. And in particular, I'm going to be using the version 0.17. So if you want to double check what version of FreeCAD you might be using, you can go to the About FreeCAD that you see right here, and you see how I'm doing 0.17. That's important because the 0.17 build, which is like the pre-release build, introduces a pretty new way of doing the parametric modeling that we're going to be doing right now. So make sure that you've got the right version. Now, the other thing that I'll mention is that if you are downloading that 0.17 version, you are basically going to be downloading a binary file, which means there's really nothing to install. You're just going to have a folder that you unzip, and then inside of that, you're going to go into the bin folder, and that's where you're going to find the executable for FreeCAD right here, which I have started up. So let's dive right on in. The first thing I'm going to do, right up here on this icon, I'm going to create a new empty document, just like that. Excellent. So you've got this unnamed document right here, but you can't really do anything directly in a document. Instead, you need to pick out one of the workbenches to work in. Now, if you click this drop down, you're going to see there's quite a few of them. The ones that we are going to be concerning ourselves with today are the part design right here. We'll also be doing the spreadsheet workbench. That's going to allow us to add variables that we can use in our parametric modeling. And then we're also going to be using the mesh design workbench, which is what we're going to need to access in order to export our model when it's ready to go. So let me flip on over into part design. This is your workhorse right here. This is where you're going to do most of your modeling work. And you can see a couple of changes have occurred in the toolbar here. I've got this create a new part, and I've got this create a new body. So first off, we're going to click on the create a new part, just like that. And then I want to point out to you the combo view over here. And it's got two tabs, model and tasks. Now tasks is here to kind of give you a hint of, probably what you want to do next. And it is prompting us to create body, but we are not exactly doing that. If you click on the model, you can see there's the part that we've just created. And inside of it, it's got what's called an origin point. And so this is the starting point for this part we're going to create. Now, the reason why we're doing that is because as your model goes on, you might need more than one part, right? Now, inside of that part, our next move is probably to create a body. So I'm going to click on this create a body right up here, and you'll see from the tooltip that it's going to automatically make that body active, which is great. So I'm going to click on the body. And if I expand that down, you can see that it's also got its own origin point. In fact, if you open that up, you're going to see XYZ axis, XYZ planes. And this is the information that's going to use and apply to every single model that we do inside of this body. The reason why we're doing it this way is because let's say we're doing a model like maybe a couple of tires and an axle, and you just find it easier to model the tires lying down. But then when you're done, you want to rotate them upright to attach to the axle. Well, by doing it inside of a body, you would be able to rotate the entire body, and all the settings that you've done inside of that body will also be rotated relative to that origin point. So that's kind of why we do that. But for this example, we probably don't have to concern ourselves too much with that. It's just good form for us. So all of the modeling work that you do in FreeCAD and most of these CAD programs is done via sketches, and they are exactly what they sound like. So in a second, I'm going to create a new sketch and we're going to start modeling out our box. But before I do that, I'm going to do one more step here, which is switching workbenches. And I'm going to go over to this one called Spreadsheet. Now that may not sound very exciting, but what we can do with it is going to be super, super cool. So let me click on Spreadsheet. And as you see, my toolbar has changed again, as it does every time you change the workbench that you're working on. Now, although you've changed workbench, you're still working on the same document over here. You can see that that has not changed in the combo view. But what I can do, if I click on this icon right here, I can create a new spreadsheet. Awesome. Now the way that we can get in and start editing that spreadsheet is by double clicking it. So let's take a look at it. So Spreadsheet is FreeCAD's way of keeping track of variables that you need. So I have in mind that I am going to model out a little credit card holder box here, but I want to do it in a way that I'll be able to use this same box for pretty much any box that I'm ever going to need. All right. So probably the first thing we need to think about is plugging in some values for the credit card. And that is going to be what we call the base for this model. We're going to use that information for creating a lot of the other parts of our model. So first of all, I'm going to plug a value right in here, and I'm going to say card X width. So this is basically how long the credit card is. Now I measured earlier using a set of calipers, and my credit card is about 80 millimeters wide. There we go. So you can imagine the next thing we're going to plug into here is probably the Y height. And I believe that was about 48 millimeters, just like that. Now there's one additional step that we have to do here in order to be able to access this information while we're modeling. And I can show it to you very simply. If I right click this 80 millimeters right here and I go to the properties, you're going to go all the way over to this alias tab and basically give this a name. Now it can be the same as what you plugged into column A there, and I don't see a real reason to change it, so I'm going to call this card X width. But there's one more setting you need to plug in here, which is what unit of measurement you're using. So I'm using millimeters, and I'll plug that in there. And when I hit OK, watch the property inspector down here on the left. So I hit OK, and check it out. So it's now been added to the property inspector here. That's what you want to see. That means that this value can now be linked to in our models when we get to modeling. So let's do the same for the card Y height. Properties, go to alias, plug in card Y height, just like that. Don't forget the display unit is going to be millimeters. There we go. So we're going to use this information for creating a very basic model, and then we're going to build the rest of our model around that. Now, the advantage of doing it that way is that these values are now dynamic, and we can actually change them. So if I go in here, for instance, I could say, oh, maybe my cards are only 70 millimeters, right? And when I do that, if we build our model right, it will simply recalculate the entire model with no breaks or no seams or anything like that. So that is the power of parametric modeling, which I'm sure you can agree is a little more powerful than the basic modeling that we did last week. But it's not going to be too complex. We just have to plan it out. So this is going to be my card width and height, but I think I need a couple more values in here. So first off, I don't want to make this box like so tight to this card that it's difficult getting the card in and out. So I should probably have some sort of a clearance in here. I'm going to call that clearance my card offset, just like that. And maybe I'll make it like 2 millimeters. I want to keep this fairly slim but I don't want it to be like jammed so tightly. So now you already know what to do. We're going to go to the properties, give it an alias, and I'm going to call it the card offset, just like that, and plug in the display unit, which is millimeters. There we go. What else? I want to know, I want to have a constant value for the thickness of the walls on my box here. So let me put in another parameter. I'm going to call it wall thickness. And what should we go with here? I'm going to say maybe 4 millimeters. This is to your individual taste, of course. And we're going to right click that, go to properties, plug in the alias, which is the wall thickness, just like that. Display unit, millimeters. And that is looking pretty good. Now, as we go, we might find that we want to plug a few more values in here, but that's a pretty good start. So we can head back to our actual model, which is our second tab down in here. And we're going to click on the body. Now, you can see I don't have my modeling tools in here yet, but that's because I'm still on the spreadsheet workbench. So now let's head over to the part design, which we mentioned is kind of our big deal here as far as modeling goes. Now you can see in the tasks that is already prompting us that we probably need to create a sketch. But just before we do, let's go to the model. Let's make sure that the body is highlighted, which it is. And then we'll click on this little icon, create a new sketch right here. Now when we do, it's going to ask us what plane we want to model in. So this again is up to you. Maybe you want to start modeling from a side view of the model that you want. For me, I want to kind of have a top-down view of this thing. So I'm going to select the XY plane, which is the first option here. Hit OK, and boom, now we are into modeling mode. So if you haven't done a lot of modeling in CAD programs, the thing to remember is that it doesn't really work the way modeling works inside of other programs like, say, 3D Studio Max, where you're maybe modeling game assets and so forth. In CAD modeling, you basically just lay down any old shape, and then you're going to go back and you're going to plug in very precise values to indicate what you're trying to do with that shape. So I've selected the little square here, which you can see is a couple of points combined with a couple of lines. And I'm just going to plunk it down any old shape because I'm not really relying on eyeballing this thing. In order to make sure that this is the size I want, I have to start applying two different things. The first is called constraints, and the second is called symmetry. So I'm going to right click to get out of my square drawing mode here. And I'm going to click right on this top line. See how it's like highlighting yellow when I go over it? Now if I left click on that, it's selecting it. And then right up here, these red icons that we see, these are my constraints. Now this little one right here, which you can see looks like kind of like a letter H. Well, this is going to be your horizontal constraint. So if I click on that, I have the option now of plugging in a value. So I could say, hey, you're going to be 40 millimeters, just like that. And it'll make it exactly 40 millimeters, which is basically why we call it a constraint. But I'm not really looking to use a solid value like that. Instead, I want to make use of the values that are in my spreadsheet so that if I make a change in the spreadsheet, it'll automatically get recalculated on this base model here. So to change it, you can double click on the constraint. And then if you look carefully, you've got this little FX icon. If you click on that, you're now able to add a formula into this thing. Now, let's start typing. So I want to go to the spreadsheet, and as soon as I type the S, you see how it's prompting me with spreadsheet? So I'm going to click on that. It puts a dot, and now I can start pulling values out of my spreadsheet. This is why we had to add aliases in the spreadsheet. So let's see, what was I after? It was the card X width that I set. So I'm going to click on that. And then you want to click the first OK here, not the second one yet. You're going to hit OK. Now you're going to see it's like sort of faded out gray here where it says 80 millimeters. And the reason why is because like it's just showing us the value that it has calculated, but it is doing that using the formula. If we click inside of here, we can edit the formula, right? So we're not working with a hard value anymore. So I'm going to hit OK again. I don't really bother with a name here. If you want, you can name your constraints, but for a simple model, I haven't really needed to do that. So I'm just going to hit OK. And now it's 80 millimeters. Now you can see we're zoomed in pretty far, so I can't see the edges of my model anymore. But if I just hold Control and I hit the minus, I can zoom out a little bit. So you can probably guess what we're going to do next. Well, you're right. We have to model the height of this thing. So I'm going to select this other vertex right here. And I'm going to hit a constraint, but I'm not going to hit the horizontal one, am I? You can probably guess I'm going to need to hit this vertical constraint. So let me do that and then plug in a formula. So I'm going to hit the FX. I'm going to go to my spreadsheet. And this time, I'm going to go with the card Y height. I like to name my parameters this way, just to be really, really descriptive, because if you get to tumbling around and moving this model around, you can get confused pretty quickly if you don't have like really descriptive parameters. So let me click on that card Y height. I know that's exactly what I want. I'm going to hit OK, and I'm going to hit OK again. Now this is looking pretty good because this is the exact size of the credit card that I want to use as the base for the model that is going to kind of grow up around this credit card. But I'll point something out to you. Over here in the solver messages, you see how it says under constrained sketch with 2 degrees of freedom. Well, what does it mean by that? Well, essentially what it's telling us is like, you've given me the width of this model. You've given me the height of this model, but you haven't given me any position information. I don't know where this little point is supposed to start. Now that can be a little confusing unless you get used to the idea that everything in CAD modeling works around axes. And you can actually see those center axes as I'm moving around. As I hover on one, see how it changes color like that? So this is where our second property of the sketch comes in, which is called symmetry. What it means is that if we select a couple of points and then we specify an axis that we want to apply symmetry to, it will make sure that those points have an equal amount of space between them and the axis on both sides, even if it means moving the model. Now, once it does that, the CAD program is able to calculate the X and Y positions, and it gets rid of that under constrained sketch message that we're seeing over here. Let me show you what I mean. I'm going to select this point right here. I'm going to add to the selection by left clicking this point here. And then finally, I'm going to click on this axis. Now when I do that, the CAD program realizes this is an axis that I'm clicking on. And my next action, this little icon right here, is for symmetry. Now watch what happens when we click this. Boom. See how it moved my model over? And now it is exactly proportioned to the left and right of this axis. And if you notice, our solver message now says we've only got 1 degree of freedom still in there. So we need one more constraint. Can you guess how we would do it? Well, we have solved the horizontal position problem. Now we need to solve the vertical one. And we do it the exact same way. So we're going to click this point. Going to click the bottom point down here. Going to click the axis right here. And we actually can click the exact same button for symmetry, because symmetry is not like the other constraints where we have to specify horizontal or vertical. Symmetry is just symmetry, and it's based on the order that we have clicked on the points and the axis we have selected. So let's hit that symmetry, and we should see it line up vertically as well. And boom, just like that. And see how the whole thing turns green? And it says in a green message here, fully constrained sketch solved in 0 seconds. That solved in 0 seconds basically has to do with the complexity of your model. If you've got like tons and tons of points in here, it may take a little bit of time to recalculate when we make a change, but we're not going to get anywhere near that level of complexity in this model. So we don't really have to worry about that. So this thing is pretty much good to go. Now here's a very, very important step that you need to know about. Right now, if I try to take other actions like going to other workbenches and so forth, I may run into problems with not being able to continue. And the reason why is because we need to finalize this sketch. And we do that by clicking on this little close the editing of the sketch. You can also click the close tab button right over here in the tasks. It keeps it up there for you because it knows that you pretty much have to close every single sketch you will ever make in here. And you'll see as we go that models are just made up of groups of sketches. So let's go ahead and close this one out. Boom, just like that. And if we click back over to our model here, we can see that we've got a closed out sketch. Awesome. Now, currently we can't see that on the screen. And the reason why is because, once again, we're actually zoomed in too far so that our sketch is actually outside of our frame here. If we want to fix that so we can see it, go ahead and click on the fits the selected content on the screen icon right here. And boom, there it is. And if you'd like to see it in perspective, you can click this first little icon here, set to axonometric view. Boom, just like that. And now we've got this nice little 3/4 view to view the thing with. Pretty awesome, right? So that is the first step. We have created the base model that we will use as the source for all of our measurements of the rest of the model. All right, let's take a quickie break. And when we come back, we're going to get into designing our parametric box based on this base model we've done. Okay, my friends, we are back and we are looking at the very basic model we have made of our credit card. We built this model based on values that we find inside of our spreadsheet right here. Now, our next goal is to basically build up our project box around this model. And if we do it right, we'll be able to make changes to any of these values and see our model get remade before our very eyes. We'll be able to make project boxes of pretty much any size that we want. All right, so let's get in there. First thing we're going to do is make sure that we're highlighted on the body because we're going to add a new sketch to this. So let's go ahead and hit that new sketch. We're going to use the XY plane like we did before. Boom, just like that. And what are we looking at here? Well, we are inside of a new sketch, but we can actually see the geometry of our old sketch, the credit card sketch that we did. Now, we aren't able to access that yet, but we are going to need the information about the width and height of this thing if we're going to build our model correctly in a parametric manner. So first off, let's just make a really basic rectangle. This is going to be the outer walls of our box that we're creating. So we're not going to worry too much about measurement because we're going to do this with constraints so that it'll be super accurate. Now, we mentioned that we need the information about this other model here, but as I move over it, you can see that it's not highlighting or anything like that. Now, I could try and eyeball my dimensions from this, but that is not what we want to do. Instead, we're going to use a tool that allows us to bring information about another geometry into the sketch that we're currently working on, so that if I highlight over something, we're going to see it change color. The tool that we want is right here, create an edge linked to an external geometry. So I'm going to click on that, and now as I'm moving over, see how it's highlighting? I want to make use of the 2 points and the line right here to create a constraint for my outer walls. Now you'll see how we're going to do that in a moment. For now, I'm just going to select that. It's going to turn purple, which means that that information is now accessible in my current sketch, even though it's part of the other sketch that I worked on. So I'm going to right click to unselect that. Then I'm going to click right here on this first point. I'm going to click on the second point. And now we're going to make a constraint using a formula, just like we did for the credit card model itself. So let's do the vertical constraint first of all, right here. So it's making a suggestion, but that's not what we want. We're going to click on the formula button. We're going to go to the spreadsheet. And let's think about what we need here. So there's our card sitting in the middle. And we know that just around the outside of our card, we've created a card offset, just like that. But we're trying to model the outer walls of our box. So we're going to need to add in, once again, going to the spreadsheet, our wall thickness that we set in the spreadsheet. Going to hit OK again, and boom, there's the first part of our constraint. And because we've used a formula here, you can see that it's showing up in orange. Now it looks a little hard to read, but if you just kind of grab that, you can pull it until it is looking good. Okay, first part is done. Now we need to create our horizontal constraint as well, which is exact same. Now you'll know you've selected these points properly when they turn green, just like that. And so now let's add in our horizontal constraint. And once again, we're going to plug in the exact same formula. We're going to go to the spreadsheet, get our offset, and then we're going to add in, once again from the spreadsheet, our wall thickness. Yeah, there we go. Boom. Hit the OK. Hit the OK. And that's in there. Now you'll notice in our solver messages, we're getting the same message that we got when we modeled the card itself, that we're under constrained. And you can probably even just visually see why that is. Notice how skinny this is over here. So how do we solve that? Well, the same way that we did when we made our first sketch. We're going to use symmetry. So let's select, here, let me pull this out of the way here so it's not confusing us. I'm going to select my point right here, select my point at the bottom, and then I'm going to apply symmetry around this axis right here. So let's hit the symmetry button. Boom. See how that's like repositioned? That's looking pretty good. Now we need to do the same in the other direction. So I'm going to select this point, select this point over here, and this time I want to use the vertical axis to apply my symmetry. And boom, just like that, we've got our outer box. You can see it all turns green, and we get fully constrained sketch. All right, do you remember what we have to do now? Super, super important step. Very easy to forget. We have to close out the sketch. Now, when we close this, it doesn't mean that, we aren't able to edit it. We can definitely go in and we can do anything that we want with this. But what it does mean is that any formulas we've created are going to get calculated. So let's click on that close, just like that. And now we get to have some fun. Now that the sketch has been closed, which means that it's a complete shape, we get to apply some of the other properties that we see here to it. Specifically what we're after is this one, pad a selected sketch. You may know this as extrusion. Let's go ahead and click that. And just like that, it's going to suggest 10 millimeters of height, which sounds pretty good to me. So I'm going to hit the enter, and boom, just like that, we've got a project box. But it's not just any old project box, because this is now a fully parametric model. Let's test it. Let's go to the spreadsheet here, and let's say, oh, you know what? My cards are actually only 50 millimeters long. Maybe there's some kind of weird shape. Boom, just like that. And if we go back to our model, see how that's changed? Awesome, right? And we can do the same thing with any of the properties here. So I'm going to switch this back to 80 for now, because I actually do need a credit card holder. There we go. And that is the end of this second part of our video, guys. We've got a fully parametric box. Now you can probably guess what we're going to need to do next. We're going to create something called a shell, which is basically us pushing a pocket or a hole into the middle of this thing. We're also going to need a little bit of a lip around the edge there that we can use to insert a cover into. It's going to be great. So join me in the next segment and let's get down to business. Okay guys, we're doing really good here. We've got our parametric box ready to go. And as I move my cursor over, you can see that I'm now able to highlight the various faces of the box. So the way that it works in most CAD programs is that you always come back to using sketches. And once you have a face made, you can actually apply a sketch to it exactly as if you were drawing on it with a marker, and then you'll be able to apply operations like you see up top here to that new sketch that you've created on the face of your object. So here's what I'm going to do. I'm going to click to select this face right here, the top face, and we're going to go about modeling via a new sketch the pocket that we want to create. In other words, the depression, the hole that we're going to create in this face. So now that I've got this selected, I'm going to go ahead and I'm going to click on a new sketch, and you'll see that it will know, it won't ask me to select what plane that I'm doing this in. It's going to do it in the plane of this face here, which we know is the XY plane. So let me click on this new sketch right here. And so there's the top of our box, right? This is the pad that we created visible right here. So with no further ado, let's go ahead and throw a rectangle on here as we've been doing all along. And then we're going to see how we can do our constraint on this thing. So in order to do this properly, parametrically, so that this rectangle we're making for our pocket can also change based on our credit card changing, well, we need to make sure that our constraints get applied to that credit card shape. But right now, we can't actually see the credit card shape. And the reason why is because the pad is getting in the way of us viewing this. Well, fortunately, there's a way to change that. So let me right click to get out of my rectangle tool. I'll go back to the combo view and look at the model. And if I click on the pad and I right click, I've got this option, hide selection. When I do, the pad is hidden from view. It's still there. If we go out of this sketch and back to our axonometric view, we'll still see it, but it's useful for me in this view to hide it so that I get access to my credit card geometry right here, because we're going to use that to make our next set of constraints on this point right here, which we'll be using to basically punch a hole in our model. So do you remember how we can bring in information from an external geometry to use in our current model? Yeah, we're going to head right to this right here, and then we're going to highlight over the geometry that we need and click it. Perfect. Okay, so now let's exit out of the external geometry tool, and we can start putting a constraint on this box right here. So if this is our credit card, and we are now cutting our inside wall for our box, what dimension are we going to need to use? It's going to be the offset, that little 2 millimeters clearance that we're leaving around the outside edge of our card. So let's do it parametrically. By now, you're probably starting to get used to this. So I'm going to click on this little point right here. Then I'm going to click on this little point right here so that they're both green. And we can go either way. We can go with the horizontal constraint. We can go with the vertical one. Let's do the horizontal this time. All right. So let's think about what our formula is going to need to be here. It's actually going to be really simple. We're going to go to our spreadsheet, and we're going to ask for the card offset. And that's all we really need. I'd hit OK, just like that. There's our little 2 millimeter offset. Let's pull this over so we can see it properly. And as you can expect, we need to apply an offset as well to this point. But I'm going to show you a slightly different way of doing it that might be useful to you if you find yourself applying a lot of constraints in your sketch. We're just doing rectangles here, but sometimes you might be getting into some more complex shapes, and there may be a little bit faster way of doing this for you. So here's what we're going to do. I'm going to click on this point right here. I'm going to click on this point right here again. I'm going to apply my vertical constraint, but I'm just going to leave it with whatever default it gave me. Now you see how this is showing up in red rather than in orange because we haven't applied any kind of formula to this thing, and that's perfectly fine. Now right now, if we look in the tasks, we're going to see that we're under constrained, but this is the point that I wanted to make to you guys. You can close down a sketch even when it is not fully constrained yet if you want to do some work inside the property inspector on the thing. So here's what I mean. Let's try this out. I'm going to close out this sketch, and you can see like it is clearly wrong, right? Like one of the lines is right, but the rest, they're pretty bad. So let's go to our model here, and we're clicking on sketch number 2, the one that we're working on right now. And you can see in the property inspector here, pretty much all the properties of the thing are listed out. If I click on the constraints and expand that downwards, you can see we've got one that uses a formula, and we've got another that just uses a hard value. Now you can actually copy the formula from this one, and you can paste it into any other constraints that you've got on here, which can be really useful sometimes. So I'm going to highlight on the first one that's got the formula. I'm going to click the formula button, copy the formula, just like this. I got to say OK, because I don't want to discard that. Now I'm going to go to the second value, click its formula button, paste that in there, hit the now here's kind of a funny little thing with the UI here. If I just hit enter, it's not going to keep my formula, and I can't actually click on the OK button down here. So what you have to do is actually click the card offset to accept its hint there. It gets you out of that drop down, and now you can hit OK. You got to remember, FreeCAD is open source. It's still in active development, and you are going to find little UX issues like that from time to time. Okay, so now if we go back into the sketch, you'll see that both have the formula, and it has now picked up the information that it needs. So now we can go about doing our other operation, which is applying symmetry, so that we can get this right and this bottom cleared up here. So let's go ahead and do it. So we're going to click on this point. Going to click on this point. Click right here on this axis, and we can apply the symmetry to it. Boom, just like that. Now let's do the same thing for the horizontal axis. So we're going to click here, click right on over here, click on our vertical axis, and apply the symmetry. And now that looks pretty good. Now you can see that it toggled back on the pad, but I don't mind it in this case. Once we've made our selection of the external geometry, you can turn the visibility of the pad back on, and you'll still be able to do all kinds of selections on the purple geometry that you've brought into your current sketch. So that's all looking pretty good. I think we are ready to once again close this out. So this is another point that you got to keep in mind. If you go back into edit mode and you make changes to a sketch, you must close it out again when you are finished. Looking pretty good. Boom, just like that. So now we've got our nice little section here that we want to use to carve into our box. Now to do it, let me click on the model here. We have to make sure that we're still highlighted on the sketch, and we can do an apply a pocket right here. A pocket is going to cut into the model, almost like the Boolean operation that we did in last week's session. So let's go ahead and click it. And now we're getting this 5 millimeters that it wants to cut into the thing. Now, as you can imagine, we can do a better job with the using a formula here, because we've got a parameter called wall thickness, and we want to make sure that the bottom of this box has at least that wall thickness. But rather than doing it here, let's practice doing it through the property inspector. So I'm going to hit enter and leave that as is. Then I'm going to highlight that pocket. I'm going to go down here to the length right here, and I'll apply my formula through this. Okay, so let's think about this. What do we need here? Well, we basically need to know whatever the height of the entire pad is, and then subtract from it whatever wall thickness we want to leave for the floor of our box. This is something new. We haven't seen this before. Inside of these formulas, you can access things via the spreadsheet, but you can also access them via the hierarchy that you see over here in the model. So watch what I can do. If I start typing pad, I can select it, and that is the actual pad that we are using in the current model. It puts a dot, and if we start typing, we can see that we have an option to select the length, which is essentially the height of the pad that we've created. So let's click on that. That's going to give us the height of our project box. Now, let's go to our spreadsheet and remove from that the wall thickness that we want. Nice, right? No calculations needed. And what's really good about this is that if we go back to our pad and we change the length of this, let's bump it up to like 20. We'll double the height of the thing. See how our shell maintains, and it instantly recalculates parametrically to maintain the floor of our box? Pretty awesome, right? So now at this point, we've got a box that we can change its outer dimensions simply by going to the spreadsheet. We can add to or decrease from its height, and the whole thing just magically recalculates to keep everything nice and orderly. So we're doing really, really well here. The only thing that we have yet remaining is to basically cut into this thing a little lip that we can use for inserting a little lid into our project box. So that's what's up next. We're getting really, really close to the end here, guys, and having a really, really nice, useful project. Okay, my friends, we are really close to wrapping this up. We're going to get a little bit fancier with our formula this time around, because we're going to be cutting into this surface right here to create a little edge. So just like we did before, we're going to select the top surface. We're going to see it turn green, and we're going to apply a new sketch to it. Let's click on that. And just like before, we've got a little bit more visible here than we really need to be seeing. Once again, we're going to be modeling against that first model we created of the credit card. So let's go to the model right here. And this time we're going to click on the pocket, and we're going to toggle its visibility off. We're going to hide that selection. There we go. So by now we recognize this. This is our credit card model, and we're going to use the external geometry tool to bring information in from it to our current model. So first off, let's get our square going on here. Just like that. Okay. Oh, just like that. Boom. And let's get our external geometry brought in right here so we can work on a constraint. Great. Okay, now let's think about this one a little bit. So this one's going to be a little bit different. We're actually going to use just a tiny little bit of math here, because I basically want to divide the wall thickness in half in order to create the pocket for this little lip that I want to use for inserting a lid into the top of this box. Let me show you what I mean. So I'm going to click on the first link right here. I'm going to click on the second point right here. I'm going to go to my horizontal constraint, and as you might have guessed, I'm going to go to the formula here. And let me bring up my spreadsheet, and And I'm going to ask for the wall thickness, but look what we can do. We can actually apply math right inside of here. So see how it says the result's going to be 2 millimeters? That's because if you remember, our wall thickness is set to 4 millimeters, which means that we're going to be plunking this line directly halfway through our wall, all the way around the outer edge of our box. But let's not forget, we also need to include that offset. There we go. So that's that little bit of space between our card and the inner wall. That looks pretty good to me. I'm going to hit OK. Let's grab this and pull it out. And so it's saying basically from the edge of the card, we're going to be making a cut into our wall at precisely 4 millimeters. Awesome. Let's do the same thing for the vertical. So you can see there's a little bit of repetition in this, but you can't get sloppy. It's really easy to lose control of this stuff. If you just take your time and you're precise with it, you'll have no problem. So we're going to say spreadsheet, get the wall thickness, divided by 2, and then add in the offset. So it's the spreadsheet. And we need that card offset there. Beautiful. Now, because of the way we've done this, we would actually be able to change the wall thickness via our spreadsheet without disrupting our model. And that could be pretty handy, especially if we get to 3D printing this and we find it's going to take far too much time. Maybe we thin up the walls, and you'd be surprised how much time that can save in your 3D print. All right, by now you probably know what I'm going to do next. We're going to apply symmetry to get rid of those final 2 open constraints that we've got. So let's apply our symmetry along the vertical. Let's do the same thing for the horizontal. So clicking this point, clicking this point, clicking that center axis, and applying the symmetry. And boom, just like that, the whole thing turns green. If we go to our tasks, fully constrained sketch. Perfect. So let's go ahead and close this sketch out, just like that. And here we are back in our 3/4 view. And you can see that we're pretty much ready now to apply a pocket to this thing that will give us our little inside edge for a lid. So let's do it. I'm going to click on the pocket. Here, first off, let me go to the model here. I always like to take a look and make sure that I'm on the right sketch. And now I'm going to apply a pocket to it, just like that. And it is suggesting 5 millimeter. Now, do we really need a formula here? Well, I'm going to say we don't really need a formula here. And the reason why I'm suggesting that is because everything else we've done, we've wanted to be able to change it if our credit card size changed. But would the lid thickness really change based on a change in the dimensions of the credit card? Not really. This particular stat is going to be more based on what material we want to build that lid from. So I'm saying in this case 5 millimeters is a little bit deep. That's not going to leave a lot of room for putting cards inside the thing. And maybe I'll back it off to 3 millimeters. And this one, we can pretty much just leave as a constant. And that, my friends, is looking pretty darn good. We have a fully parametric project box. We can change any of the dimensions, make any size of box that we want. We can make it taller, we can make it longer, and every single time it will come out perfect and ready for 3D printing. So how do we actually do the 3D print? Well, in the next little segment here, we're going to visit another of our workbenches called the mesh design. We'll need that to output the STL file that we're going to use for generating our G code. So let's do it. Okay guys, this is exciting. We've finished up our first parametric model in FreeCAD, and now we're ready to output it into an STL. So how do we do that? Well, there's a couple of ways you can go. There is actually plugins for FreeCAD which will allow you to output your STL or even G code directly, but I kind of prefer to do a step-by-step approach, simply because FreeCAD is in active development, and I don't really want to rely on a lot of plugins in FreeCAD. I'd rather use separate tools for some of the steps, like slicing my STL into G-code. So let's just kind of do this step by step. Now, before anything else, I'm actually going to give this file a save, just in case anything should go weird. So I'm going to hit save. I'll give it a name, Parametric Box 2, and I'm going to save it as a FreeCAD document. That way it's going to preserve all of my information in the spreadsheet. So give that a save. And now here's what you want to do. The fastest way of doing this, the simplest way of doing it, is you're going to select on the bottom-most operation that you've done in the stack for this body here. That's going to save you a little bit of time when you get to the next step here. So from Part Design, you cannot export an STL file. You're going to have to actually switch over to Mesh Design and turn your current selection into a mesh. Now, when you do that, it's going to look a little bit weird, but trust me, this is going to import just fine into our slicer software that'll generate the G-code for us. So let's go right up here to the Meshes option, and we're going to say Create Mesh from Shape. Now, click on that, and you get a couple of options here. So I would recommend that you go with the standard meshing options right here. If you go more in depth with CAD modeling, you can definitely get to playing with these tessellation settings here. But for your first time, I recommend just taking the default options here. Let's just get an STL created. I'm going to say OK. And now we've got this Pocket 001 meshed. So see how that matches up with the name of the shape that we had highlighted here? So now you're going to select to highlight the mesh that we've just created. Now, as you can see, it does look a little bit weird because it looks like it has discarded some of the information here. But not to worry, that has not happened. Let's go File. And now we have an option to export, and it's actually guessing that we probably want to do an STL here. So let me make this my Parametric Box Mesh 2. I'm going to save it to my desktop. And now if we shrink this down, here we've got a nice new STL file. Okay, so just to refresh your memory, an STL file has all the information about the points and the lines inside of our model, but what it doesn't have is toolpath information. For that, we need to do a slicing operation to create another kind of code called G-code that has recommendations about the way that our print head should move when the 3D printer is doing its thing. So the one that we make use of is called Cura. Here we go. Cura, bring that up. And this is going to show us if our whole operation went properly here. I do not want the new version of Cura, which is not compatible with the printer that I'm using. Okay, so here we've got Cura open. This is where the rubber meets the road. We're going to load that model file. We are looking for our Parametric Box Mesh 2 STL. I'm going to open that up, and boom, just like that, a perfect model complete with the inset that we created for a lid. And it says it's going to take about an hour and 30 minutes to print fully. Are we able to generate G-code from this? Well, let's find out. We're going to go File, Save G-code, and save it on my desktop. And there we go, my friends. G-code ready for uploading to 3D printer. Yeah. So last time around, I showed you guys how to access Octoprint and submit your G-code into the queue for printing. So yeah, let's go for it. Let's make this box. Okay guys, time for the thrilling conclusion. Time to find out if our model is going to work. So I'm over here at the 3D printers. We've got our printer bot ready to go here. So just to remind you, these are all networked up. We've got a network interface called Octoprint that I'm going to use to submit my G code, and let's see how it goes. So first off, I'm going to jump to the IP that I see written right down here in my browser. And then the step that I always forget, I got to make sure that I'm actually logged in. So here we go. And yep, sure enough, nope, actually I'm still logged in from yesterday, so that's cool. So now I'm just going to take that G code file that we created that's on my desktop. I'm going to drag and drop it right into Octoprint, and we'll see what the time estimate is. So, grabbing my G code, uploading it. Looks like it's already uploaded. Cool. Yeah, so it's saying about an hour and a half, but let's just get this started here. So first thing I got to do is warm up the printer by setting the material, which is PLA, which is has a melting point of like 205 degrees. So I'm going to hit that. And then we've got a little minute to wait here while it warms up. Once it's warmed up, I'm probably just going to extrude a little bit of the material just to make sure that there isn't like any clogs in the nozzle here. It's just something that you can do to improve the success rate of your print. The other thing I'll point out is that I'm not just printing my model, I'm also printing it on top of what we call a raft, which is an adhesion technique. So a raft basically does some wide crisscrosses before it begins printing your actual model. And it does this to basically create kind of a semi-permeable layer between your model and the bed. It'll help it stick, but then later on, it'll also be helpful when we pry our model off this thing. This is going to be about, if you remember, about 80 millimeters wide. So it's going to be fairly wide on the bottom there, and it's going to really stick. So without that raft, we'd have a heck of a time trying to get it removed from the machine. So I'm just going to go to the controls here. I'm going to fire off a little bit of extrusion, and I can hear that running. It's feeding through. It's coming at the bottom nicely. So I'd say this thing's ready to go. Let's print it. Well, my friends, the print is all done, and we very nearly nailed it dead on, but not quite. When you're dealing with such fine measurements, it's really hard to get it right first time out of the gate. But that is where our parametric modeling is really going to save us. Let me show you what I mean. Okay, guys, check this out. So when I go to put the standard size card into my holder here, it fits like almost perfectly in the ledge with just a tiny bit of clearance, and it doesn't quite make it into the base, right? So we need about 2 millimeters more all the way around, and then this thing will be bang on perfect. So let's do it, right? All we got to do is go back to our parameters, add another 2 millimeters on both the X and Y of the card, and we're good to go. Saved by parametric modeling.